We'll go over the graphing part of the calculator workshop. So again, following the handout, we'll be concentrating on what this top row of buttons will do for us on the calculator. Go ahead, press the window key, and mine is set on the default, -10, 10, 1, -10, 10, 1, and 1. If yours don't match these, go ahead and change them by typing in -10, enter 10, etc. What this does for us is tells us what window will be displayed when we're doing a graph. If we go ahead and hit the graph button at this point, the X-min, -10, is the leftmost point of our graph. X-max, +10, is the rightmost point of our graph. Y-min is the lowest part of our graph, and Y-max is the highest point of our graph. So this is what we call our viewing window. To get back to the home screen whenever you're graphing, you can always press second mode to quit, and now we're back in our usual part of the calculator. Okay, so now to graph a function, we're going to hit the y equal key. And again, I've already cleared out my equations, but if you've got some equations in here left over, you can always hit clear to erase them. The equation here, example 1, that we're going to graph first is y equals 3x subtract 5. The y equal is already in our calculator, so we press 3, and then this key here will give us a variable x. At this time, go ahead and ignore these other values here on this button. 3x subtract 5. Okay, and then to graph it, we'll press this key, and we've got our graph of the function. If you press trace while we're here, we get x and y coordinates of various points on the function. Get this little spider here. And if you decide to press either left or right, that spider crawls along the graph, giving us coordinates of various points on the graph. To leave this again, we can press second quit, and we're back on our home screen. To erase that function, we can go back to y equal and hit clear. Now let's put in and graph y equal x squared plus 10. So we'll start with the x, and we can use our shortcut key for squaring. We could also have done -2, and then plus 12, x squared plus 12. So when we graph this one, something should happen, but it doesn't, does it? And that's because of our window. X squared plus 12 is the graph of a quadratic function that's been shifted vertically up 12 spaces. So it's actually up here off the top of our screen. So what we're going to do is go into the window, and what we want to do is enlarge the window. I think I'm going to not quite follow the handout here. I'm just going to take the Y max and let the Y max be 20. And there's our graph. It was hiding from us before because our graph only went up to +10 here. It was off the edge of the graph. Anytime you change your window, you can always take a look at what values you have there. Values do not have to be symmetric. We could make this window go from -5 to 5 and 0 to 20. There's no such thing as a perfect window when you're graphing, but try to get a window that shows enough detail to see what's going on and eliminate some of the parts that you don't really use, any blank spots in your window. Lost my spot here. Okay, so next we're going to use the table feature. So we're still going to leave that x squared plus 12 in our y equal function, and then we're going to press second window to get to table setup. And again, your settings might be different than mine. I'm going to change mine so my table start is at 0. Delta table here, this is going to be the step, how large of a step my table is going to take, and I want both of these to be highlighted on auto. Then I'm going to press second graph to look at the table, and I'm getting these values here. So what I'm getting are nice values of x and y on the graph. When we trace on the graph, we don't always get nice clean values like these. Once you're here, even though we set the table to start at 0, we can scroll up and down in the table and have our table start at -4, and we could have it continue as far as we like. Okay, let's clear out that one. We're going to put in another function. This one's got a fraction, so we're going to group the fraction in parentheses. 9/5 x plus 32. Okay. Losing my spot in the handout here. There we go. And then we're going to go into the table set again. And this time, instead of auto, we're going to change our window so that the independent is ask and the dependent is auto. And when we go into the table, second graph, nothing's there because it's wanting us to type in the values we want for x. And this is handy when you've got some specific values of x you want to calculate, and maybe they're not falling in nice close intervals to each other. So sometimes setting it for auto is better, and sometimes setting it for ask is better. Whenever you do change it from auto to ask, it's always the independent. Always leave the dependent on auto, so it's automatically calculating the y value for the x value. Okay. Finding x-intercepts of a graph. Let's now go into our y=. We'll clear this one out, and we're going to graph 2x subtract 1. And we're going to set the window to be our standard window. So right now, I've got a crazy window. The shortcut to setting the window back to -1010, -1010 is to hit the zoom key and then standard, which is 6. And that automatically sets my window back to that -1010, -10 to 10, which works well, 90% of the time. Okay, now hit the trace key, and we've automatically started off at x = 0, y = -1, which is the y-intercept of the function. So we can move the cursor sideways and try to get the x-intercept of the function. But it's a little hard to spot. It's somewhere in here, somewhere between x.42 and somewhere between x.63. So one way to find the intercept is to zoom in on that point, which we could get by changing the window. But the quicker way to do it is get the cursor close to where we want to zoom in, hit zoom, 2 for zoom in, and then enter. And the screen jumps and gives us a detailed picture of what's happening of our graph, centering itself on where our cursor was before. We can zoom in a few more times. And get more and more detail. And if we hit trace, then we're right on the graph. So with 2 zooms in, I know I'm somewhere between 0.49 and 0.505 for my x-intercept. And again, I can zoom in and again. Another way to find this is to use a 0 function in our calculate menu. So calculate is up here at second trace, and option 2 is 0. And this helps us find an x-intercept. A 0 is another name for an x-intercept. And what I need to do is tell the calculator a value for x that is left of the actual x-intercept, which I can do by tracing, or I could enter a number and say that my right bound is maybe 0.6. And then my guess for the x-intercept, again, I can either cursor over and hit enter, or I could have typed in a value. And then I wait a minute, and the calculator automatically zooms in to the value of x. That makes y = 0.